So I'm Sven, not the Sven Sauleau one. This was the joke. You can find me on Twitter at this handle. I'm speaking French if you want to talk to me. Otherwise, that's fine too. I live in London, and I work for Cloudflare. I think that's funny. Well, OK. So in case I say anything bad, views are my own, not Cloudflare's. And today's talks will be about JavaScript, about WebAssembly, sorry, or WASM for short. And I want to show you how we can use it in JavaScript. And the agenda of this talks is I want to show how we can use it today and the future of it. And also, I want to talk a bit about how you can help move WebAssembly forward. I found this quote on the internet. It's quite accurate. So WebAssembly is a way to take a programming language that isn't JavaScript, compiles it to something, and this something can run in a web browser. It can also run in Node.js, or thanks to WASI now, it can run on a standalone implementation. So it can run pretty much anywhere, which is really neat. Which also means that JavaScript doesn't have the monopoly on the web anymore. It's open to many languages now. So let's talk a bit about types. WebAssembly has 4 primitive types: floats, ints, both in 32 bits and 64 bits. You also have memory in table, but it's not relevant here. And don't get me wrong, any language that compiles to WebAssembly can make use of these types to build more rich types, like an object or a string. So as I mentioned, I want to show you how we can use WebAssembly in your day-to-day JavaScript project. The first thing you need to keep in mind is that WebAssembly needs JavaScript. It needs it because it's heavily sandboxed, and without JavaScript, it can do pretty much nothing. So to be able to fetch a resource or to access the DOM, you need to import JavaScript functions inside of it and call it. Which also means that if WebAssembly needs JavaScript, it can't kill it, right? That's the deal. So you can also see WebAssembly as a black box. If you're familiar with JavaScript modules, on your right-hand side, you have JavaScript imports that you feed into WebAssembly. Then you have some code that is running. It's Rust, C++, whatever. You don't want to look into it. It's compiled code anyway. You don't need to care about it. And then you get JavaScript functions back, or JavaScript exports. In my example, I'm importing a foo function, which takes an int and returns an int. And then the WebAssembly module will export a bar function that I can call in JavaScript to get an int back. Anything that is inside of it, you don't need to care. And so here's the JavaScript API for this. First, I have my imports, which is a JavaScript literal. Then I call WebAssembly.instantiate with my WebAssembly module, which is a JavaScript object. And I pass in my imports. Then I get back an instance which has the exports of my WebAssembly module. In my case, I have a sum export function. This process is called WebAssembly instantiation. You might be wondering now, I mentioned that WebAssembly only has 4 primitive types that you can interchange between JavaScript and WebAssembly. But imagine you want to implement React in Rust or C++. How can you access DOM nodes? How can you access JavaScript objects? Or how can you just pass a string between WebAssembly and JavaScript? So today's workaround is that don't worry too much about this code. WebAssembly can expose its memory to JavaScript. And then JavaScript can take this memory to do whatever, which means that it can extract strings out of it and get JavaScript strings out of it. Or it can do many things with it. Actually, Vlad will be talking about this a bit later. To access DOM elements, the current hack is that you can maintain a list of DOM elements on the JavaScript side, and then only pass pointers or fake pointers to it, to WebAssembly. WebAssembly can then call a JavaScript function with that index, and that JavaScript function can make use of it by resolving using the map to get the DOM reference. Anyway, if you want to exchange types between WebAssembly and JavaScript, we need a better way to do this. We need a better interoperability, something that we can use conveniently. So what I would like is that I would like first to import my WebAssembly like I import my JavaScript, using the latest JavaScript syntax. So here's an example of my project module graph. I have an entry point, index.js, that imports my app.js file. This app.js file imports a WebAssembly module. The WebAssembly module is opaque. They can be anything. In my case, I have a C++ library with a Rust program compiled. But also, this can be an NPM dependency. Maybe you don't even know that you are using WebAssembly today. I want WebAssembly to be integrated into my module graph. And lucky us, this is called ECMAScript module integration. It's currently phase 2 in the WebAssembly process. If you're familiar with JavaScript modules, you can just import the WebAssembly module and get exports out of it. So in my case, I have my add function, which is implemented in the math.wasm file. And I can import it, call it, just like a regular JavaScript module. Similarly, I can, in WebAssembly, import a JavaScript function, which is exposed by this module.js module. The foo function can contain any JavaScript code. WebAssembly can call it. And also, imagine now, if the WebAssembly module can import functions from JavaScript, it can also import NPM dependencies. That's a big improvement. We hidden the instantiation part, the JavaScript slide as shown you earlier. Imports and exports are now riot for you behind the scenes. The module is being handled by the browser. Imagine manually instantiating your JavaScript modules. Nobody does that. The browser does it for you. So this is for WebAssembly. And something cool is that this is actually available now in Webpack. Other bundlers are coming soon, too. So as a side note, here's an example of how you can use it. So on the bottom, I have my C file, which has an add function. And on the top, I have my entry point, which imports that C file. Webpack, using a loader, can match against that C file, compile it behind the scenes, and return a WebAssembly module within Webpack. The user don't even see it. And so WebAssembly gets bundled along JavaScript. And hot reloading works. You just have a great UX. Everything is just perfect, right? So my second dream is that I would like to call WebAssembly as I call my JavaScript. I want to pass JavaScript objects, DOM nodes, any JavaScript value. But remember, I said earlier, WebAssembly is restricted by its type system, only numerics or functions. So there is one way now. We have something called reference types. It's currently phase 3 in the WebAssembly proposal process. It allows you to take any JavaScript or DOM reference and pass it to WebAssembly. WebAssembly will see it as an opaque pointer. It cannot know what's behind it, but it can pass it to other JavaScript functions which can make sense of it. You can also store it in WebAssembly. And so here's an example. On the first line, I can get a DOM element. I can call WebAssembly a WebAssembly function that will render something on the screen. And this is done without any glue code that I showed you earlier. as I said, less glue code. We reduce the glue code, which is a huge developer gain. Another proposal is called interface types. It's phase 1. I'm not going to spend too much time on this. It's new. It has many talks already on it. If you're interested in it, go watch online. But the gist of it is that this is extremely poorly phrased, but it's a way to take a JavaScript value which has a certain representation in memory and turn it into another representation. For example, I have a compiled C module which exposes a high function and expects a C string. JavaScript doesn't share the same layout than C does. So you need a way to convert them. And this is the glue code, again, which did this earlier. But now, with interface type, it's going to be converted from a JavaScript string to a C string behind the scenes for you. Similarly, you can return a string. The C string gets converted to a JavaScript string. And this is not only restricted to strings, of course. You will be able to exchange objects, callbacks, etc., anything. Again, less glue code. It's way easier now to call a WebAssembly module. Function, I mean. Lastly, you have the begin integration. It's phase 3 in the WebAssembly process, very close to being standardized. So if you are not aware of the begin object in JavaScript, it's kind of new. The background of it is that JavaScript only has float 64-bit numbers, which means that you cannot represent WebAssembly int 64-bit in JS. It's pretty cool because Dan, he's in the audience somewhere, wrote a proposal, this proposal, to be able to use the begin object when you're returning an int64 from WebAssembly, such that you can actually represent it and use it. Here's an example. On the top, I have a C function, which is exposed and takes an int 64-bit and input and outputs an int 64-bit. And then on the bottom, I have my JavaScript. So the little n is a begin literal. I can call my function with the begin and get the begin back. And this is a bit special to me because with the help of Egalia, who Dan is working for, and V8 help, I actually implemented this in V8. It was actually the first time I worked on V8, and it was really the best experience of my life. It's also getting into Firefox pretty soon. The point is that everyone can contribute to standards, to implementations, or help us define what we should do. For example, so there's something called the WebAssembly Community. You cannot probably read it, but Community Group, whereas community just means the entire community. Proposals are going through this group. New ideas are being discussed there. They have a bi-weekly call. You have GitHub also, where you can discuss over issues. And the point I'm trying to make is that please voice your opinions. Please voice your concerns, and please help if you want. You can propose something. You can implement something. And that was my last slide. So thank you.